Hello and welcome to another episode of Peep and EIP, an EIP dedicated video series where we consider one proposal to understand why and how's by the author itself. Today we have got a very special guest who has been here on the show earlier to talk about another proposal, EIP-173, the contract ownership standard that is already implemented in Open Zeppelin and some of the other projects. So if you are working on something similar, must watch that episode. I will add the link below. Welcome back, Nick. Very happy to have you here. Today we are going to talk about another proposal, that is EIP-2535 Diamond Standard. But before that, please introduce yourself to our new viewers.
Hi there. So I'm Nick, and I'm a developer, a standards author. And I've worked on various projects, been working with Solidity and Ethereum for a couple of years. Okay, so let me share my screen. All right, so I thought I'd start off with some benefits of a diamond. So a diamond is a contract that implements the diamond standard. And so let's look at some reasons why someone might want to have a diamond. Okay, so the first reason here is a stable contract address that provides needed functionality. So this is really for upgradability, so that if you want to, diamonds can be upgraded and they keep their address, just like if you're familiar with other upgradable contracts like Open Zeppelin's proxy contracts. This provides the same benefit here of when you can upgrade your diamond to add additional functionality to your diamond to do different things, and you have a stable address. It's not going to change. Okay, and then so the second benefit here, a single address with functionality of multiple contracts. So one thing that's different from diamonds versus proxy contracts like Open Zeppelin's proxy contract is that a diamond utilizes multiple contracts, whereas Open Zeppelin's proxy contract, it just has one implementation contract, and only proxy contract only pulls functions from one contract, whereas a diamond can pull and use functions from multiple contracts. All right. Okay, good. So a question might be asked, well, why would you want to have a diamond that can use multiple contracts? Why not just use one contract for its implementation? You know, like a regular proxy that just uses one implementation contract. Why use multiple? So there's different reasons that you might want to do this. One reason is for fine-grained upgrades, which means that if you have a diamond and it provides some functionality and you realize that you want to change something in the contract, you want to upgrade it, then maybe you just want to change one small thing. Or maybe you just want to add one function or replace one function. And with a diamond, you can do that. You can upgrade your diamond just replacing that one function, or just adding that function, or just removing a function. Whereas in a proxy contract, you have to deploy your entire implementation contract with all its functions. You basically have to redeploy the entire functionality over again with your small change. So that's one benefit of a diamond, is that you can change just the parts of the diamond that you want to change and nothing else. All right, so there's I have on this list a number of benefits. I'm not going to discuss them all because this is more of an introduction. Oh yeah, so one other big use case for diamonds is it solves the 24 kilobyte maximum contract size limitation. So this happens with upgradable contracts where you have your upgradable contract and it's great. It's implementing your non-fungible tokens or your DeFi protocol, whatever your system is, your upgradable contract is doing it. And then you realize that you need to upgrade it to add some more functionality, so you do. And then you realize you need to upgrade it again with some more functionality, so you do. You find more use cases, you get feedback from users. There's all kinds of reasons why you might want to add additional functionality. One of the things that can happen is you'll hit the max contract size limit. So like contracts on Ethereum can only get so big, and then they can't be deployed anymore. And that max is 24 kilobytes. And the diamond doesn't have that problem. And it doesn't have that problem because it uses multiple contracts or implementations. And for the diamond standard, we call it faucets. So diamond uses multiple faucets. So you really can have as much functionality as you want in a diamond. It's not there's no size limitation on it. So that's nice. If you're upgrading and improving functionality, you don't have to run into this limitation that stops you. Yeah, so then go ahead.
I may have a question here. So this contract size limit, I understand that this is something added in like a later version of Diamond protocol, right? Diamond proposal that you had initially. So why not to come up with a separate proposal for that, or why to add it in the existing one? Does it add value to your existing proposal?
No, it's always been there.
I'm sorry, yeah. I got confused with the Diamond storage version.
Yeah, no problem. It's okay. Oh, maybe you're thinking about diamond storage. Yeah, that was something that was added. Yeah, we can cover that. That's right. There's diamond standard uses something called diamond storage, which was added later to the standard.
Yeah. Right.
So yeah, so we could cover that in a little bit, or we could cover it now.
I'd say why don't we try and make it through the benefits? Like if you've got like another one or two benefits that you want to highlight, and then maybe we will start diving into like sort of the technicals of how it works and how it does all this, if that's okay.
Yeah, sure. So I mean, another benefit is this, and I've kind of already gone over this develop incrementally and let your diamond grow with your application. So, just that you can, deploy your diamond to a test net and have people start using it and then get feedback and then go ahead and upgrade your diamond. And then there's another thing about a diamond is it's upgradable, but you have the option of making it no longer upgradable anymore. So that can help with development if during testing or you're letting users try out the application on a test network, and you can upgrade it as much as you want. But for this particular application, you want it to be immutable when you deploy it on Ethereum mainnet. You have that option with a diamond where you can just make it so that it can no longer be upgraded. But
that also means that you can pick some of your benefits. It sounds like if you want to be able to split a very, very large contract into a few smaller diamonds, you're able to do that, but without necessarily having the proxy contract pattern of upgradability. Is that correct?
That's right. I mean, one of the nice things about a diamond is that it's using these different faucets. So you can split your functionality among these different faucets, and that helps you organize your code. So related code is in its own faucet. Is that kind of what you're talking about, or just breaking up your diamond into different diamonds?
I meant more just picking and choosing what you like, what parts of these benefits you want. Like you could get the split code so that you don't run into the 24 KB limit, but still choose to make it immutable. Like you don't have to necessarily take all of the options that you're offering here. You can sort of customize how you want to use your own diamond.
Oh yeah, that's very true. I mean, the diamond standard and making a diamond is very flexible, so you can design it and get the benefits that you want and not get, and ignore the things you don't need. It's very true. Yeah, so I'd say that's some of the good benefits there. I mean, another benefit is that there can be in some applications, there can be some gas savings using a diamond because a diamond can be unlimited in size. It enables you to access contract storage within a diamond without having to do external function calls to other contracts. So because things are all in one diamond, it can reduce the amount of function calls that are going on, which reduces gas costs for some systems.
Great. I have actually a bunch of questions about gas, so I'll be interested in getting into that once we get into the more technical part. This might even be a good segue into that, about how you managed to pull it off. So like, what's the magic? What's going on under the hood here?
Okay, good. Yeah. So let's look at that. All right, so what is a diamond? How's it implemented? So as has been discussed, a diamond is a contract that gets its external functions from other contracts. And inside a diamond, it has a mapping which maps functions to other contracts. And these other contracts I'm calling faucets. Like faucets from a diamond, different sides of a diamond. So what happens when you call a function on a diamond, then the diamond uses that mapping and goes, oh, this function is being called, and that function comes from this other faucet, and it's able to pull the code, the function from that other faucet, and execute it within the diamond. So the diamond really uses other contracts as its library of functions. So that's that in a nutshell. That's how a diamond works.
So you're sharding, basically you're taking a contract, more or less sharding parts of it into libraries so that the contract can then import all of its functions using the library techniques that Solidity reveals.
Yeah, I'm saying the word library more conceptually. The Solidity has library functionality. I'm not using library functionality here. Solidity's library functionality. I'm just more conceptually saying that a diamond uses other faucets as its library of functions, but I'm not talking about Solidity's library.
Okay, I got it.
Yeah, but that's good to distinguish that, because what I mean by that. Solidity's library functionality does work within diamonds for things, and it's very useful with diamonds, I found. Which I can discuss in a bit later. But so the three main parts of a diamond are: one, a diamond has a diamond cut function, which is a standardized function that diamonds have. This function is used to add or replace or remove functions on the diamond. So every diamond has this function. That's how you add stuff and change it. That's the upgrade function. And then a diamond has 4 standard functions that are used to tell you what's in the diamond. Like, if you have a diamond, you want to know, well, what functions does it have? And where do those functions come from? And so these 4 standard functions give you that information. So at any time, you can look into a diamond. It makes it transparent. And then a diamond has a standard event, and this event emits anytime there's a change to a diamond. And this gives you a full historical record of all the upgrades of a diamond, everything that's changed over time.
So maybe you could detail how this differs from normal importing. Like, let's say that I'm using safe math from OpenZeppelin or something like that. So usually I can just import the contract. I have all of those functions available. It sounds like there's something much more modular happening here. So how exactly does this differ from a normal import?
Okay, so it's different from a normal import because in Solidity code, you're importing a library or another contract into your code, and then you're using that in your contract. So in this case, a diamond is a contract that's been deployed to the network. And it doesn't have, when you first make a diamond, the diamond can be deployed to a network, and it doesn't do anything. You have to add functionality to it. And so that's where this diamond cut function comes on, where the diamond cut function allows you to add functionality from other already deployed contracts. So, versus where if you're importing something, you're creating a contract that's going to be deployed, and you're importing all the things, and it's all going to be added to one contract that's going to be deployed. With a diamond, the diamond's deployed. You're adding things to a diamond after it's deployed.
Mm-hmm. So for a normal import, you're saying that we're putting all of that code inside the contract before deploy, and then that contract itself contains sort of all of the imported code inside of it also, and then it gets sent to the chain. Whereas over here, what you're dealing with is you're actually connecting components from different blocks, from different parts of the blockchain, and sort of creating a cross functionality between contracts that are already deployed.
Yeah, that's correct.
Great.
Yeah, which brings up an interesting factor. Another benefit is that, you can deploy contracts onto the network faucets, these contracts that get used by diamonds. You can deploy them to the network, and then you can deploy your diamonds, and then you can connect the two. But the cool thing is that these faucets you deploy can be used by any number of diamonds. So you have this reuse of deployed contracts on Ethereum, because you have one diamond, or you have 5 diamonds that are using the same faucets.
So essentially, you've created a kind of on-chain reusable component. No, as in there could even be some kind of service where various different high-use functions have been deployed and now can get pulled in on-chain using the standards. Is that correct?
That is correct. Yeah, and that is a bit like Solidity's libraries, because you can deploy, contracts to the network and then use Solidity's library functionality to use those deployed. So in that way, it's similar.
Very cool.
Yeah. All right, and then, so then I think the 3 main components.
So it looks like that is close to the end of your list. I've got a bunch of technical questions I'd like to ask you about this. Would this be a good time for me to sort of move into that?
Absolutely.
Okay, great. So first, just actually sort of in the coding style, I'm curious about the way that you put this together. The actual standard itself, I have not made it through the implementations and the examples that you've given. Would you say that it follows more of a object-oriented or more of a functional standard? As in, when we're looking at a diamond working, is there some kind of object that's getting mutated, or is there, maybe you could describe that process about exactly how the data is getting passed around, or how the contracts are connecting to each other and bringing in data from each other.
Yeah, sure. So a diamond uses an operation code from EVM, which is delegate call. And so delegate call allows a contract to borrow the code from another contract and execute it as its own. And that's really what a diamond does. When a external function call is called on a diamond, the diamond goes, okay, I got this function call, and it finds out, well, what faucet that function call where that function exists, and then it uses the delegate call operation code, opcode, to get that function from that faucet. And once it's got that function, it executes it as its own code, and that's what it does.
So I'm just going to chime in really quickly. When you say it calls the function, does it return the function, or is it like an opcode in the sense that it only sends out like the parameters and then receives the result?
Oh, so that's a good question. And this goes, so yeah, I can be more specific. When an external function is called on a diamond it's a contract, it's a Ethereum contract, and you can have a fallback function. And that's how it works, is a diamond has a fallback function. The fallback function is when you call a function on a contract and that contract doesn't have that function, what happens is it executes its fallback function if it doesn't have that function. And so a diamond really, in some cases or most cases, a diamond doesn't have any of its own functions. So when you call a function on a diamond, that call goes to the fallback function, and then the fallback function then uses delegate call to call the function on the faucet. Now about return, and once it calls that function on the faucet, that function might have return values, and so the diamond gets those return values and returns those return values to the caller. Whoever called the diamond gets the return values. Does that answer your question? So like when you call a function and that function has parameters, okay, the diamond gets that, forwards it to a faucet executes it, faucet has return values, faucet gives it to the diamond then go ahead and also returns the return values.
Yeah, that makes sense. It sounds that's really cool, actually. So it kind of sounds like you're sort of separating the actual computation from the contract. So that's cool. But yeah, that answers my question. Thank you.
Yeah.
I am curious about the gas overhead. Now, this might be a good time to even segue a bit into proxy contracts. Proxy contracts have been a pattern for a while and used for upgradability. But proxy contracts, to the best of my knowledge, also make judicious use of delegate call. Am I correct about that?
That's totally correct. Yes.
How would you differentiate between diamonds and the regular, so to speak, proxy contract patterns that we've seen up until now? I'm seeing with the diamonds that you can pull in specific functions. and also that there's much more granular control of those functions inside the contract. But maybe you could compare and contrast proxy contracts and diamonds.
Yeah, sure. So some of the main differences between them are, well, one of them is that I won't say all proxy implementations, but a lot of proxy implementations and Open Zeppelin's popular proxy contract implementation, they only have one implementation contract. So they work the same way. A proxy contract has a fallback function. You call external function on the proxy contract. The fallback gets executed, which then does delegate call to call on the implementation contract. So the proxy contract works similarly to a diamond in that way. Big difference is, as I said, diamond is mapped to potentially mapped to lots of different faucets, not just one. And so that also solves the max contract size problem I talked about earlier. A proxy contract will run into the max contract size if it gets too big, because it only has one implementation contract, and that implementation contract can get too big. But a diamond could have tons of faucets, and they could all be small faucets, so they never hit the max contract size.
Would you need to make more delegate calls using a proxy or using a diamond, or would it all come out the same if we would compare, like, you know, a specific flow of calling a function using the two different patterns?
Yeah, so that flow is very, very similar. So with a proxy contract, you know, the external call happens, the fallback function executes, and then there's a lookup in state in contract state to find out what's the implementation contract address, and it uses that to execute the function. And the diamond is the same thing. Yeah, so it's like the flow is the same. The only difference is that I think a proxy doesn't really need a map to map the function call to the implementation, because the implementation contract is the same for all function calls. Whereas a diamond, you have to have an actual mapping that maps function calls to faucets. But basically the flow is the same there.
So gas cost between the two should be roughly analogous. It should be roughly the same gas for either a proxy or for a diamond. That's
correct. They're the same.
I would actually like to segue from that into the topic of gas. So it's by pushing storage off to the different facets on the diamond. So it seems like you've solved a lot of storage issues, but by pushing it to delegate call will make calling these functions slightly more expensive. Do you see that as being prohibitive, the level of gas spending that's going to have to happen?
Right now, I don't see it as prohibitive. It's, you know, with the diamond, it's sort of, it has qualities that mitigates itself for gas. So that it, you know, because you're calling delegate call, there's a little bit more gas to call a diamond or a proxy contract than calling a regular contract, but it makes up for it in a few ways. One of the ways, for example, is that when you compile a contract, Solidity has an optimizer, and the optimizer has basically a setting, and the higher you make that setting, the more gas efficient the contract becomes when you call functions on it. But also, the higher that setting, it becomes more gas efficient when you call functions, but it also increases the bytecode, the size of your contract. So what happens if you just have a single contract, or if you're using a proxy contract, and your contract is getting large, but it's not hitting the max contract size limit, you can't have a very high setting. I mean, in some cases, it depends how big your contract is, but if your contract is getting close to the limit, then you can't have a high setting for the optimizer. So then you have to have it lower, which means the gas cost to call your functions is more, because that setting is lower. But with a faucet, your faucets can all be small, and you can put that setting as high as it can go, and so your faucets will be really gas optimized when they're called, because you're able to use this high setting that, you know, that's one. Another one is because a diamond doesn't hit a max contract size limit, you can add special use case functions to your diamond for gas cost reasons. For an example is like, let's say you're implementing a non-fungible token a contract, and you realize that you might want to have batch functions for transferring a whole bunch of your non-fungible tokens at once. You can do that in a diamond. You can implement those functions, and you can implement other functions that give you gas savings possibility. And again, you're not going to hit the max contract size limit. So those are just a couple examples where, with a diamond, you can do these extra things for gas.
As in, you're saying that you've definitely got a balance here, even if you do end up spending more on delegate calls versus regular function calls. The fact that you can optimize a number of smaller contracts much more easily than one large contract already should offset gas costs to a certain degree. And certainly also if you're talking about people who are running up against 24 kilobytes. So it's not like they really have another option in the cards anyway. I mean, yeah. Yeah.
And then here's another case for gas optimization is that if you're using regular contracts or proxy contract, and the contract gets too big, okay, now you break your contract up into 2 smaller contracts, okay? And so for these 2 smaller contracts to work, they have to call each other, and those function calls between each other cost gas. But if you use the diamond, all that functionality is within itself, and this function call between contracts is not there, so you save gas there because you don't have to make an extra function call. Does that make sense?
I didn't actually fully understand that, so if you could say that over again, I'd appreciate it.
Yeah, sure. So if you have a contract that gets too big, and so you decide to break that contract into 2 contracts, and
but without using proxy, you actually just literally split it into 2 contracts and have the contracts call each other.
Yeah, you have them call each other.
Okay, now I got you.
Yeah, but that calling between each other costs gas, and you won't have that gas if you just use the diamond.
I understand what you're saying. I did want to ask you, I saw that Trail of Bits should be auditing the standard. I wanted to ask about, are there potential dangers especially with using the fallback functions this way? Or maybe I'll put that in a more general sense. In general, people a lot of times are loath to put extra functionality inside fallback functions. What are you doing to make sure that that is secured, and what are your views on the security audit and why we should need a security audit for this?
Yeah, so I don't see any security problem with the fallback function. As long as the fallback function is written right, then it's fine. I guess one thing is that the fallback function, like you don't want to add a faucet you don't want to add a function to a diamond that calls self-destruct. If that makes sense, if you do an external call on a diamond, and a diamond, calls that function on a faucet, and that faucet calls just self-destruct, that deletes the entire diamond.
Mm-hmm.
So I mean, but that's like a stupid error, and like, any functions that you add to a diamond, you should know what you're adding. And it's very easy to look in the source code of a function and go, oh, look, because I don't think I've ever used self-destruct yet. So like, I mean, but so like you don't want to call self-destruct, and have a faucet and a function that calls stuff, unless like you really want to do that. You want to delete your diamond for some reason in some particular case. So like I would say that the fallback function is secure and good, but like as a Solidity programmer, you can of course mess things up. But some of these ways to mess things up are so stupid that you don't see them as a security threat so much as not knowing Solidity well itself is a security threat. Yeah, not knowing Solidity, or I mean, I don't know what else exactly. So there's that. Let's see, there's another case. This is another security thing, and security thing is that you can have a faucet that's deployed, and then you could add this faucet to a diamond, and then maybe that faucet again has self-destruct in it somewhere. So you don't call the faucet through the diamond. You just call a function directly on the faucet itself, and that function has self-destruct. And so basically, if you delete a faucet that's been added to a diamond, now the diamond's going to try to use that faucet when it doesn't exist anymore.
And what would happen there? I'm assuming just all the delegate calls would fail.
Yeah, so
They'll burn gas, but you know.
Right, it'll fail, or like the calls will succeed. Well, the calls will succeed, but they won't do any like.
Okay.
Succeed, but it
Yeah.
won't do anything. So it's possible to in that fallback function, it's possible to add a check to see that your faucet actually has code in it or not, so that to prevent this case where before you call your faucet function, you check, is there contract code there, and if there is, then you go ahead and call it, and then that prevents you from thinking you ran a function on a faucet when you didn't. But I don't put that in the fallback. I don't put that check in the fallback because it costs gas, and
right.
I just think that people should not use they shouldn't be if they don't want self-destruct, they shouldn't use it. It's like a bottom error for them to use it when they don't want to. Open Zeppelin's proxies does the same thing. They don't do a check for code before calling the implement. They don't do it either for gas reasons. They also think that people shouldn't add implementation contracts to their proxy that call self-destruct. But for example, Trail of Bits, I don't think agrees with that. They think that you should always check that a contract has code before calling delegate call on it. That's how they feel.
Okay. I mean, that probably does get into the internals of how audits work, and if everything that an audit turns up needs to be fixed, and all of that. But yeah, I understand the stylistic differences that you're talking about. Yeah.
Yeah. So after all these technical details, now let's just come out about the usage. I have heard that many of the projects have already started using this proposal in their project. They have started implementing it. So would you be able to help us understand the proposal being used as decentralized on-chain governance, and which are the projects that they are already using it?
Yeah, sounds good. So there's a company called Derivadex, which is they're building a decentralized exchange on Ethereum that is for derivative tokens. Buying and selling exchange stuff. So they're using the Diamond standard, and they're using it for their governance. And so the idea is that, and they have a governance token as well. So the idea is that the people who have their governance token, they can vote on proposals that changes how their exchange works, how people can submit executable proposals that can be executed on chain, and if people vote for it, then it gets executed. And they use the Diamond because it allows proposals to add, remove, or replace functionality to their protocol. Because Derivadex is built basically as a diamond with a bunch of one big diamond with a bunch of functionality, and now the community has the ability to add, remove, or replace functions to that, and so that's the idea. There's some security things that Derivadex is handling, like they have to make sure that any proposals that get executed are good, and that they're not bad. They don't do bad stuff. So that's what they're doing. And then there's another DeFi protocol which is called Barnbridge that wants to do something similar, where they use the Diamond again as a way for their community to cause changes to their protocol.
Right. So when we talk about the governance token, this proposal, does it has to do anything related to how much share a person should be getting? Because that's very important in governance. And when it comes to DAO and other stuff, it becomes sometimes challenging, like how much voting right should be assigned for a particular thing. So does that also answer those kind of queries? It helped the proposal?
Yeah, well, I know that Derivadex, they have, I think they're going to release their source code sometime for their thing, but it's the token, and based on how much token you have more voting rights and things like that. And I don't know if that answers your question, but yeah.
Right. So if I understand correct, that is the project that has asked for audit, right?
That's correct.
Okay.
Is that a fully on-chain procedure? I'm just curious. Like, I mean, does the voting trigger everything on-chain, or is there still some off-chain coordination involved with that?
It's on-chain. Yeah.
Yeah, I was reading about this proposal somewhere, and I found that the Bond Bridge, as you mentioned, the upcoming project, that has actually written some good words about this particular proposal, if I may read out for the people here. Bond Bridge DAO will be a DAO that is controlled by the bond community. The Bond Bridge DAO will have full control over the protocols and the features that are built into it. We are doing this through the use of the Diamond Standard 2535, which allows us to upgrade to the protocol without having all the members removed from their token, and to switch to a version 2 of the protocol that time arises. And the Bond Bridge DAO will have full control over the diamonds, which provides amazing flexibility in the Web3 space. I have seen this challenge when a DAO is moving from one version to another version, upgrading. They have a lot of issues related to their voters, their members stuff. So it's really interesting to know that this proposal is going to answer those questions and is very helpful. I must congratulate you for that. Before this proposal become finalized, it is actually being used by some of the projects.
Oh, thank you. Yeah, there's more too. Like there's a game, it's like called Either Real. I kind of forget at the moment, but there's a game that's that has non-fungible tokens and NFTs, and that's using the Diamond Standard. Using a diamond. Avagachi is a project that's using the Diamond Standard.
Yeah, I meant to ask more about Avagachi, like how is it being implemented there? Like, I mean, like if you can give us an overview of it.
Okay, sure. Yeah, I mean, I can tell you that Avagachi, it has a lot of interesting functionality. It'll have a lot of on-chain interesting functionality. It has composable parts where you have an Avagachi is this creature, this ghost, and it can have wearables. So you can hold a wand or a sword, and that's going to be on chain. So you'll have this non-fungible token, which is an Avagachi. The token will actually be able to own these other tokens, these either fungible or non-fungible. So you'll have this composability where tokens are owning other ones, as Avagachis can also hold ERC-20 tokens and stuff like that. I've started the implementation, and it's the composability part so far has been based on another standard, which is ERC-998, which allows this non-fungible tokens to own other non-fungible tokens and other composable functionality.
That's great. So I have been seeing that there has been a lot of stress towards the educational resources. About this proposal, you think that more educational resources are required here?
Oh, totally. I've been promoting like people who make videos and tutorials about Solidity to also start writing more about this. It's more of an advanced thing. I think a diamond, like someone just learning Solidity and learning a diamond is too much. But after someone gets comfortable with Solidity, then learning a diamond is a good thing, and education would definitely help on it. Yeah.
I see this proposal is it's in the draft status, right? And the next state would be to move it to the last call, right? So how ready is this proposal to move into the next state?
That's a good question. So let's see. I think it was released in like March of this year, the Diamond Standard. So it's still pretty new, and it's really, I feel like it's really improved and gotten better over time. So you know, I always think that the standard is like, oh, it's not going to change much. It's probably pretty much done. But then something happens, and you know, something gets discovered, or I learned something, or someone else learned something, and then there's more to add to the standard, or even take things away. I've taken things away, and then I've added stuff. So I don't know when I'll move it. You know, I guess when things stop improving. But you know, right now it's you know, again, I feel pretty confident right now that it's not going to change. I think right now the only thing that's going to change in the standard is that I'll add more like information, like more security considerations, like we talked about. Don't call self-destruct with delegate call. You know, that's a security consideration. I could add that to the standard, so just like more information. But as far as like changing the the specifics of the specification, like, you know, it's I don't know. Like right now, I don't know of any changes to add to it. I feel like I probably won't change it, but it could change. Yeah. I mean, the standard's really flexible, and people, and that's the thing, is I'm excited to see what people do with it and create.
That's interesting. So, I mean, like, it's safe to assume that it may take a couple of more months to get into the next state, because that's author's choice, right? When author is ready, he can move it to the next state and move it to the last call, and then editors will review it again, and further it will proceed.
Yeah, yeah. And I want to mention, so as we talked about earlier, the Diamond Standard came out in March, and it was written a certain way, and it was fine. And then some months later, I did a pretty big rewrite on it, because this new thing was made possible, which is diamond storage, which solves a problem with this pattern of having a fallback that calls other contracts. And the problem is how to handle state variables. Like, so with a proxy contract, you know, you have an implementation that has state variables, and then when you upgrade with a new implementation, that new implementation might have different state variables. And so the alignment and coordination of state variables between upgrades has been a problem in the past. And so diamond storage really helps solve the problems with that and basically what diamond storage does is it allows developers to create a namespaced section of contract storage, like you can specify a place in contract storage for functionality, and that's part of it. So that then you can have, you know, different faucets can have their own places for their state variables, and it's also possible for faucets to share their data in a diamond, and so a diamond storage makes that possible. But that only you know, this diamond storage capability was only made possible earlier this year when Solidity language changed. There was this new feature that was added that made it possible. So that's what happened with there, and that's always a really great benefit, addition to the diamond standard, which didn't have that before.
That's great. So with that, I think that we have learned more about this new proposal. I was reading, like there are a lot of, as you mentioned, that you have been writing blogs about it, and I have read it in so many places. It's a good proposal for decentralized on-chain governance. I hope that it becomes standard really soon, like whenever you are ready to move it to the next stage, because that's already been implemented in some of the projects. With that being said, I hope to see you again, Nick, because I see that there are some more proposals coming up from your end. For people who are watching us on YouTube, contact details of the account where you can follow would be provided in the description section below. And leave your questions, comments. We will bring it to the authors if you have any further, and if you are implementing it, let us know more about it, so that we can support every proposal that is coming into this series. Hope to see you guys soon again with another episode of Peep and Eep. Till then, goodbye. It's Pooja, Ranjan signing off. Thank you, everyone.
Thank you.
See ya. Yeah. Okay. Have a good one.
Bye. It was really great speaking to you.
Thank you.